Hi, I am Rodrigo from UFRJ in Brazil, and I'll talk a little bit about deep neural network inference offloading. A deep neural network has neuron layers where each layer receives an input, processes it, and generates an output. For example, on image classification, the inference consists of classifying a given image received as an input. In this example, the output can thus indicate if this image corresponds to a dog, cat, or another animal. So, the neural network receives the input and processes all layers. The output generates a vector which has the probability for each considered class, dog, cat, or other. So, as the dog class has the highest probability in this vector, the neural network states that the image represents a dog. There are a lot of applications that use deep neural networks to build cyber-physical systems. For example, autonomous vehicles. We can take a photo of a traffic sign and perform actions such as stopping or slowing down the car. Another example is smart manufacturing systems. The neural network can receive the sound of a machine and perform fault identification. However, we have some challenges to employ deep neural network on cyber-physical systems. On the one hand, deep neural networks are increasingly become deeper. On the other hand, cyber-physical systems may use devices with low processing power. The low processing capacity of these devices can make the inference time unpractical to real-time applications. A possible solution is to rely on an external server, such as a cloud server. So, the device can send the image to the cloud, and the cloud processes the layers and sends back the output. However, it takes time to send the image and wait for the output. So we have the same problem with the inference time as before. A possible solution is edge computing, making the server closer to the end device. It reduces the problem, but we can still make it better. So, our research considers the adaptive offloading approach. The idea is that we don't need to process all layers for some easy inputs. For example, these photos easily indicate a dog. As we use few layers, we can process it on the device. More complex inputs are offloaded to a server, which processes all neural network layers. To perform adaptive offloading, we need to employ early exit neural networks. Let's see an example of image classification. Note that we have early exits after some layers. Let's see how it works. The neural network receives the image. When the data arrives on an early exit, it calculates a probability vector and checks the confidence. The confidence is the highest probability value in this vector. A low probability means that we do not trust the classification result. So each early exit checks for a threshold. If the confidence is greater than a threshold, we end the inference. In this example, we do not reach this criterion in the first layer because the confidence is 0.5. So we need to go to the second one. The second layer achieves a confidence higher than the threshold. And the inference stops because we can have a certain confidence that this is a dog. Another idea needed to perform adaptive offloading is deep neural network partitioning. In this idea, the first layers are processed on the device and the other ones at the server. In this example, the output of layer 2 is sent to the server if the confidence criterion is not achieved. So, less data is sent to the cloud. Also, the end device processes only a few layers. A complex image, for example, may reach low confidence on an early exit. And then the data can be sent to the server. The server runs all the remaining layers, achieving a high confidence. We have some work on adaptive offloading. This first one shows that early exits can calculate confidence values higher than the actual ones, leading to bad offloading decisions. However, we show that simple calibration techniques solve this problem. Please scan the QR code for more details about this work. We have another work that shows that image distortion also impacts offloading. For example, when a moving device takes a picture, it can be blurred. The blurred image may be difficult to be classified on a traditional early exit. So, we have proposed a new neural network architecture that detects the distortion on the end device. Then, it sends the data to an expert early exit on the device, trained on a specific distortion type. Please scan the QR code for more details. Thank you very much, and you can get my contact info here.